So this is From Rails to Elm and Haskell. So as a bit of a preface, I've given a few talks in my time about sort of technologies that are outside the mainstream, which I think Elm and Haskell are. Rails, not so much. And a common question that happens afterwards is people say, okay, I know a lot about the technology now, but like, how do you actually use it? Like, why did you use it? Why did you choose these particular technologies out of all the mainstream and non-mainstream technologies out there? So this is a talk about the second part of that. So we're not going to get as much in depth on these languages, but it's going to be a lot more about the journey, about how we went and why we went from Rails to Elm and then ultimately to Haskell. Okay, so back in 2013, I was applying to 2 different jobs. And one of them I was interested in because of the product. I was like, yeah, I'd like to work on that product. It was software for English teachers to help students learn writing. This is something I was interested in and I'm still interested in. In fact, I was actually at the time building some writing software of my own on the side as a side project. I was like, yeah, that's cool. I'd like to contribute to that. And then on the other hand, there was a different company that I was interested in because of the technology stack. And in particular, there was one technology that stood out at me that I was really interested in, which was Haskell. And they were like, hey, we're hiring, we use Haskell here. Now, the reason that I was interested in Haskell, I had never used it myself personally, but I had a friend who recommended it, I'm going to say enthusiastically. I hear some laughs. Maybe you have a friend who has recommended Haskell enthusiastically. It seems to inspire that in people. And this is I would hear things like, oh, this will like change the way that you look at programming. This is the type of language that everyone should learn. Everyone should get some experience with it. And some of the things that I knew about it were it's a pure functional language, which means that everything is immutable. Like all values are immutable. You cannot mutate anything. And also, all functions have no side effects. Like if you call them passing the same arguments, they're going to give you back the same immutable result. They're not going to do any side effects. They're not going to touch anything. They're not going to read from anything. It's just their arguments and their return value. And the whole language is built out of these things. And I can see how that could kind of be like a mind-bending kind of like, wow, this really changes my perspective on things. And I was like, yeah, that appeals to me. As a software developer, I care about my craft. I love programming. Like, this is interesting to me that I would get to go and potentially work with this technology. So I was in the interview. This is a really small startup, like under 10 people. So I was talking with like the CTO at one point, and I was like, hey, so I heard you're using Haskell there. Can you tell me a little bit more about that? And the CTO says, oh yeah, I wanted to use Haskell originally, but then I wanted to be able to hire people, so I went with Scala. So I was like, oh, okay. So I didn't end up working there. I thought it was a little bit ironic that he was like, yeah, we want to be able to hire people. And I was like, well, hire different people, I guess. Because that was kind of the thing that attracted me to this company. So I was a little bit sad about that. But at the end of the day, I mean, there was this other company that I was really interested in. And that's where I ended up, NoRedInk. So helping teachers teach writing. And I was passionate about the product. And technology is only one factor among many of what appeals to me about a particular position. So this was our team back in the day. There was the 4 of us and then 1 remote guy, and there was like 1.5x of me at the time. Basically, we were a very small startup, obviously, and sort of scrapping by as best we could. Now we're a lot bigger. There's a whole bunch of us, and we basically have grown from 5-ish people to now 70 some odd people. We still all fit in one room for now, but we're still growing, we're still hiring. And this is our stack back then. It was Rails and CoffeeScript. So this is a very conventional stack at the time. CoffeeScript these days is like, wow, what is this, 2013? But again, then it was, so it's a very, very traditional stack. So I think the weirdest part about the stack was that me being sort of functional curious and having this interest in Haskell and sort of knowing these characteristics about Haskell, and also me being the front end team at the time, I was basically doing sort of functional style CoffeeScript, which I'm going to define as sort of pretend it's Haskell and just choose not to mutate things, even though I could, and sort of use avoid side effects and use discipline to sort of enforce that, even though the language isn't doing it for me. Also in 2013, a little technology came out called React. You may have heard of it. And at the time, they were sort of like explaining this pitch. I saw this, I think it was on Hacker News or something. It was like, oh yeah, so this React is a way to write your UIs where they're a pure function from state to, and I was like, yes, I'm interested. What? Pure function, hang on. So So I was like very immediately intrigued by this. And I was actually, later I discovered that actually when React came out, this is very controversial. I actually didn't realize this. I was only partially clued into these things. And apparently a lot of people, there's a huge backlash to this, which I did not know about. So much so that this guy, Pete Hunt, who was really into React and worked at Facebook, went on this big speaking tour called React, Rethinking Best Practices, where he was basically defending React. And he was doubling down and saying, yes, we are doing things differently because we think they're better and they're worth it. And the title of his talk was called Rethinking Best Practices in relation to this tweet that was by the author of a popular JavaScript build tool, Grunt.js. I was like, oh yeah, Facebook, rethink established best practices, way to go. It turned out maybe they were onto something. Since now React is downloaded more than jQuery, like the first thing ever, so it's really kind of taken off. But again, back then it was a pretty controversial choice, and in fact, it was also not only was it outside the mainstream, but it was in those early days really undersupported. I mean, there wasn't a whole like library ecosystem. There weren't all these tutorials and stuff. So thinking about getting into this because of the appeal of that functional programming aspect of the render function was controversial and risky. Worth noting as an aside, another technology that Facebook invests in, coincidentally, is Haskell. So this is Simon Marlowe. He's one of the Haskell compiler developers. Facebook hired him to work on Haskell because they actually use Haskell, not across their whole back end, but like for their spam filtering and like stuff like that. So pretty interesting that Facebook's sort of interested in these functional technologies. Also OCaml, ReasonML, there's a bunch of stuff that they do. They're pretty into it, even if the bulk of their back end is still like typed PHP. So we had this question, right? Like, this is our team. Like, we're a really small company. We're like thinking about, should we adopt React, this controversial new technology? And remember, this is not how big we expect the team to get. Like at the time, we had this image like, oh yeah, someday we will fill a whole room full of people. But back then it was like, well, it's just us. So maybe this is okay for now. Maybe it's fine for just us. Like I'm happy doing, Haskell flavored coffee script. But is the next person we're going to hire going to want to do that? Are they going to want to use this thing? Or are they going to say like, yeah, I don't want to rethink established best practices. I want to stick with Angular and Knockout like everybody else. But this was a real concern for us. And so we had to sort of balance the risks of adopting React with the potential rewards. So the risks were like, number one, no ecosystem. I mean, everybody's like, jQuery, there's this huge ecosystem of jQuery UI widgets and calendars and this and that. Nowadays, of course, people say the same thing about React. It's like, how could you use not React? You're giving up on the whole React ecosystem. We'll talk about ecosystems a little later. Of course, there's a learning curve, right? This is a whole new way of doing UIs. Like the way at the time was you mutate the DOM, and then React is saying like, hey, we're gonna have a pure function of like UI from state to the virtual DOM. There's a learning curve to that. So anybody that we wanted to ramp up on this is gonna have to learn that. And then of course, there was like how will we hire people? Will it make it easier, harder? We didn't really know. But the rewards, it seemed like we would have fewer rendering bugs, like the pitch of like, hey, it's just going to be a pure function, whatever your state is, we're just going to make the page look like that. It's pretty easy to see how that would cut down on bugs. We'd hopefully end up with more maintainable code because we wouldn't have to have as many moving parts to it. And ultimately, this is a non-trivial reward, is that we would get to grow as developers. This is like something that has technical benefits, but it's also something that would expand our perspective and let us grow our craft. And as people that care about that stuff, like, that's a selling point. That improves morale, that improves retention. It's like, that's a real concrete, tangible benefit to the company. In the same way that I was interested in applying to this company because of the technology they were using, that's a real reward to using stuff that's outside the mainstream. You can go anywhere and get an AngularJS job, but this is one of the few places where I could like actually learn React. Okay, so we decided to do a controlled experiment to try out React. So here's sort of our formula. Number one, find a low-risk project that's a good fit. So that is to say, a project where like we want to build this anyway. Probably ordinarily we would build it in jQuery, which is what we were using before. But we're going to choose to build it in React with the understanding it's going to go a little slower, but it's going to help us evaluate this technology. Low risk is really important, something that we can back out if we end up regretting it. So we like pick some small project that's something where it's like, if this doesn't go well, we can scrap it and rewrite it in jQuery, and maybe we'll lost a couple days, maybe a week or two, but we won't have lost like 6 months of like betting a whole new greenfield project on this new technology that none of us know. Step two, get it all the way into production. I think this is really important. Like it's really easy to say, oh, I did a little like hack project and I put together to-do MVC. Look, it's an example. Like that's not the same thing as getting it into production. When you get it into production, you have to deal with things like how do we build it? Like how do we deploy it? There's lots of things that can potentially go wrong other than just like, oh, I got a proof of concept up and running. And then finally, once you have something in production, you can either expand it incrementally if you like it and keep going, or you can say, you know what, experiment over, we concluded that we don't want to go further with this, and now you can back it out. So that's how we tried out React. We specifically picked the student dashboard, which had this live update feature, where basically you'd be in a classroom full of computers, students are all waiting for the teacher to press the start assignment button, and you don't really want to have to say like, press the start assignment button and then say, okay kids, everyone refresh your browsers and now you'll see the assignment pop up. You want it to just appear on their screens while they're sitting there waiting for the teacher to finish explaining and then hit start. So with this live update, this is actually a pretty good fit for React because we wanted to be mutating the screen in a bunch of different ways just based on new data coming in. And so this seemed like, yeah, this is something if we just take this one part of one page, this middle section here, yeah, that'll be a pretty good initial project. It's pretty low risk, but there's a significant real benefit. So we did. So we implemented this thing in React. And it was low risk, it was one part of one page, but it let us get React into production. So next question was, okay, we've decided on a project. What are the learning resources we have to like actually learn how to implement this thing? And at the time, it was pretty slim pickings. It was like the official React docs, some talks, some blog posts, and of course, the to-do MVC code base, which will be a recurring theme. So 2013, hey, we got it. We got React into production, and we were happy with it. We liked it, and we decided to keep using it more. So experiment result, success. All right, we got React in production. We're happy with it. We're going to keep using it. So at this point, I'm like, wow, Haskell-style CoffeeScript with React? I mean, does life get any better? I'm just living the dream. It's like, could there possibly be a better, like, nicer stack to work with? Turns out, yes, believe it or not. So 2014, 1 year later, I came across this language called Elm. And I came across it because of this blog post called Blazing Fast HTML in Elm. This is before like Blazing Fast was worn out and you weren't supposed to say it anymore, but in 2014, it was still cool. And it showed this benchmark of these popular JavaScript libraries, Backbone, Ember, Angular, React, and so forth. And then Elm, which was doing really well in these benchmarks. And what was interesting about this was that Elm, unlike the others, was not JavaScript. It was not a framework. It was not a library. It was a programming language. And it was not only that, it was a pure functional programming language like Haskell. Like everything in the language was immutable. And there were no side effects, like all pure functions. And it had this like strong type system with all these really strong guarantees. And yet it was like outperforming like pure JavaScript, like while compiling to JavaScript. That really caught my attention. I was like, wow, it's hard to believe you could do better than CoffeeScript flavored Haskell or Haskell flavored CoffeeScript with React stapled on top, but maybe this is it. So I started using this on my side project, Dreamwriter, and I tried it out and ended up giving a little talk at a meetup about my experience with it. And the short version is that it was really positive. I love this thing. I felt like I was a kid again, just like learning programming for the first time and just being like, wow, I can just like run and like make stuff, and whatever I do, the compiler just like tells me, okay, just do this, and then it's gonna work again. And like no matter what wild changes I made, it seemed like once I got it to compile again, it just worked. And the UI just did what I expected, and I was like, how is this happening? And so I became really enthusiastic about it. But at the same time, I was like, okay, let's be real. Like pump the brakes here. I'm not like, we just adopted React like a few months ago, or like now we're up to like a 7-person team. We're not at the point where I'm like thinking about, okay, we're gonna use this to work. And in fact, at one of the local Elm meetups, I was walking back with Evan Shaplicki, who created the language, and I was like, Evan, someday I would like to use this language at work. We're a small startup, we're not gonna do that, but like someday, that's a career goal for me. He's like, yeah, all right, man. So fast forward a little bit, and we've got this React code that we're working on, this new feature, and we take it out to a classroom observation. So this is something we do periodically. Like we take our code out to a classroom and actually watch kids use it. If you've ever done like user studies or something like that, you imagine like, oh man, like the horror when you see users actually use what you've built and how they use it. Imagine that, but middle schoolers. So, I mean, like everything you can imagine that they would do wrong, it's like, oh, no. And to top it all off, in this particular case, we were doing it for teaching active voice and passive voice, which is hard for adults to learn. So this was really just like, okay, we would take it out and we'd use it and we'd be like, no, okay, this is back to the drawing board, right? We'd go back and we'd say, okay, we need to redesign this because we gotta teach them this concept. This is like our value, is that like this is hard for teachers to teach. We wanna help them teach it. So we'd go back and we'd whiteboard out designs and we'd like go and then I'd basically change the React code, take like a week or two, and then we'd take it out to another classroom observation that would just totally fall flat again. And we just, I mean, more so than any other feature that I worked on up to that point, we just kept hammering on this thing, and everything we tried was just like really just fell flat when we tried it out in practice. They just weren't learning it. And at the end of the day, when we finally shipped the thing, I looked back and I was like, why was that so painful? Like, why did it take me so long in between these observations to ship a new version of this? When I'm over here on my side project, just like cranking stuff out and just breaking everything, go wee, and then once it compiles, it works again. And I realized, I was like, yeah, I mean, because I don't have this Elm compiler. And I was like, but I knew that was available. I just didn't use it because I was like, I can't do that. We're a startup, you know, we can't be that technologically, that'd be reckless. But in retrospect, I was like, no, I think I just made a mistake there. Like, even if I had taken into account how long it would have taken us to set up Elm and get it up and running and onboard everybody, like, just on this one project, it would have paid for itself in how much more quickly I could have iterated. Like, I knew that experience was there, but I was like, I don't know. So after this, and like reflecting on this experience, I was like, I made a mistake. Like, we should have just started using it, so let's not make that mistake again. Let's try it out and do an experiment like we did with React and see if we like it. So we did the same evaluation. What are the risks? Well, familiar, smaller ecosystem. React had like no ecosystem when we started. Elm had a package ecosystem, but it was smaller than, even like React had surpassed it at that point. So definitely smaller. Learning curve, again, significantly higher. React was a library. This is a whole programming language. So onboarding people, we knew was going to take longer. That was a much bigger risk for a language than it was for a library. And then, of course, this was amplified even more. How the hell are we going to hire anybody? Like, we're not going to get like seasoned Elm developer, right? Come join our startup. Like, there's just not that many people using the language. But you know, we had similar risks with React, and it all worked out fine. Like the small ecosystem, not a big deal. At the end of the day, we could use jQuery as a fallback if we needed to. Same thing with Elm. Elm has JavaScript interop, so if it was something we really needed, we could just do interop with React or jQuery or whatever we needed. Learning curve, again, like I'd managed to get over the learning curve myself on my side project. I felt pretty confident we'd be able to deal with that. And how will we hire people? Well, it hadn't been a problem with React. Maybe it wouldn't be a problem with Elm too. So the rewards were, hey, we could actually move quickly without breaking things. Like we could iterate on stuff and make big changes based on what we'd observed in the classroom and then not have to worry about like, oh my God, it's gonna take us so long just, you know, having to throw out all my tests and because the design changed so much and then having to crank on so much stuff until it gets back to a working state where we can try it again. That was a pretty big deal. Also just ending up with a more reliable front end overall. Like Elm code has this reputation for like not crashing. And so that'd mean less debugging time, less chasing down production fires. That also sounded like a pretty big deal. And finally, again, growing as developers. Like React, yeah, was sort of a paradigm shift. It was like a way to expand our horizons. This is even more so because this is a whole language. I mean, this is the real deal. This is a pure functional programming language. Yeah, that's the type of growth that I was like really looking for, that I was willing to consider another company for. So yeah, we did the same formula. Let's do a controlled experiment, try it out. So find a low risk project that's a good fit, get it into production, and then either expand incrementally or back out. So we chose a different project for this one. We had this sort of drag and drop interface that had a pretty complicated back-end business logic behind the front end. So basically like this complicated business logic didn't have anything to do with rendering, just sort of deciding whether or not you were able to drop things here or you know, what to show the user. So basically this was a good fit for Elm because it was complicated and it was something that we were tweaking and fiddling with on a pretty regular basis. So we figured, hey, it's not doing any rendering. And at the end of the day, if we end up deciding that we don't and want to use Elm, well, at least we'll have this one part of our code base that's like easier to refactor. So pretty low risk, again, one part of one page, not even any rendering. So if at the end of the day we decided, you know what, this didn't work out and we want to throw out Elm, well, at least we're only throwing out one part of one page. Learning resources for Elm, we had the official guide, which was very well written, but pretty light on details. Of course, good old to-do MVC code base, our old stalwart for learning. But actually, here we had another code base, which is my side project, Dreamwriter. So we could actually look on something at least significantly more sizable than to-do MVC. And in a lot of cases, having some existing code base that you can look at, in my experience, has been more valuable than sort of like the diminishing return end of documentation. Being able to see like, this is how to do a real thing that works is pretty valuable. So it was good that we had that. We also just had like somebody who actually knew it at this point. So unlike React, where it was sort of like learning on the job, like I had actually at this point had a few months of doing like Elm as my side project with basically all of my free time because I was obsessed with it. So I was able to help out. And so one of the main ways that our team learned Elm was basically just like, okay, I'm going to pair with you and we're gonna work together until you've learned it. Pair programming is really effective when it comes to knowledge transmission. That's like one of the biggest benefits of it. And that absolutely applies to ramping people up on new technology. And of course, once I taught those people, then they could teach other people. And now there's a bunch of people on the team who knew Elm, who didn't know it until they joined our company, but now they're able to onboard others because of what they've learned. So 2015, goal is get Elm into production, and we succeeded. And one of the things that we found that was pretty cool, and this is a release that actually happened shortly after we got it into production, was one that improved the error friendliness. Now, I used to be a Java developer back in the day, and so I'm familiar with errors like this. Anyone here ever seen any stack traces like this? Yeah. Sorry, there should have been a trigger warning on that. So this is really, I mean, like, I was used to this from my compiled languages. And even stuff like this is like intended to be humorous. Somebody posted this on the internet. It's like, okay, so this part of the stack trace comes from Tomcat, and this is from Spring, and then this is down here is from Hibernate, and like, yeah, I mean, this is not the friendliest error message I've ever seen. But contrast this with Elm. So this is like if I make a typo, let's say it says, okay, the user record does not have a faux number field. I misspelled faux number, right? It says this is usually a typo. Here are the user fields that are most similar, and it like lists out, okay, so here's like some other stuff that it could be. And then finally it's like, so maybe faux number should be phone number. It's like really just bottom lining it for me. It's like, hey, I think you made a typo. Here's why I think you made a typo. Like, it even uses the word typo. So, I mean, this is like really at the extreme opposite end of what I was used to based on my Java experience. So I was like, yeah, this is rad. Like, I love having this level of help. And it turns out my teammates did too. So this was definitely like one of the unexpected benefits of Elm. Another one was, so no runtime exceptions is kind of a tagline of Elm. Now granted, when you have a new, established large JavaScript code base and you have a brand new Elm code base, like you kind of expect that, right? So like there's gonna be a long like list of JavaScript errors that have accumulated over time, stuff crashes, it's programming, it happens. And then like, of course, at first like we deploy Elm and it's obviously gonna be much less, but what this graph of runtime exceptions isn't saying is I haven't labeled it for the years. This is current. This is like since 2015 when we introduced Elm. Now it's not that there have been 0 runtime exceptions, it's that it's 0 pixels on the graph because JavaScript's up at like 60,000 and we finally had one 2 years after we deployed it and we were like, oh, come on, we tarnished our perfect record. But the language feature that happened with no longer exists. So if only we'd waited a little longer, maybe we'd still be at 0. So it's not 0 runtime exceptions, but it's negligible. Like it's not something we really worry about anymore. Like, oh, is our Elm code gonna crash? Or like, there's a production fire, the pager went off. Is it Elm? No. So this is a really nice, like, tangible benefit. It's not like, oh, developer happiness. It's like, no, this is a real technical, like, okay, I can measure the benefit here. But yeah, there was, believe it or not, more developer happiness going from like this mismatch to like a cohesive language that was designed to actually be functional programming. So actually, there was so much that I gave this talk at Strange Loop. This is a stolen title, Make the Backend Team Jealous, because one of my coworkers who was more backend focused was like, hey man, I'm like feeling pretty jealous. Like all the front end people are so excited and happy with Elm, like, and we're doing Rails over here. And like, keep in mind, like Ruby is a beloved language. It's not like, it's like, we're doing COBOL and we hate it. They're like, yeah, just like we feel jealous because of like all the excitement and enthusiasm that the front end team has for Elm. But so like I gave this talk and just kind of like walked through a more expanded version of the story that I just gave on sort of like how we ended up with Elm, and it was well received. And as a consequence of that, not just that talk, but in general, hiring actually got easier. And what we found was that it turns out there are a lot of people who are like, yes, I would like my developer experience to be better. And so there were a lot of people who were applying, like they found out about Elm and they found out that we were hiring for Elm developers and we're like, you don't need to know it, just be willing to learn it. And they were like, cool, I'm in. So much so that it became and continues to be the #1 reason that people apply, to the point where now, several years later, I don't remember how we hired anyone before Elm. I mean, this did not happen with React. Like React, it was like, okay, it's fine. We're still able to hire people. With Elm, we're like, I don't know if we'll be able to hire people. And now we'll be like, I don't know how to hire people any other way than like having Elm and just being a magnet for people who are like, yeah, I want to expand my craft. I want to like try something new. Like we hire people who are like, I did C# for 8 years. I want to do something new. We're like, awesome. Please apply. And to the point where when we hired a head of talent, she said, I have never seen an inbound pipeline this strong. Like usually you have to reach out and like bother people to apply, but you guys, people just apply. We're like, yeah. And it's really, it's very clearly because of Elm. You look at cover letters, it's like ELM is always in there. And I should give the caveat that like we're a very remote friendly company. I don't know if this strategy would work out as well if you're like, okay, in Columbus, Ohio, we're hiring Elm developers, local only. There might just not be enough people interested in that. But for us, it's like we go from like West Coast US to Central Europe, like anywhere in between. We have people in South America. Like it's really for like, given that we have such a wide pool to draw on, like, yeah, it's been amazing. So an example of this, our most recent hire, Katie Hughes from Oregon, so she said, it's been weird transitioning to a language/framework that I can just trust. I don't really need to move to the browser and see if everything's secretly broke. So you can just like work with the compiler, and most of the time if it compiles, it just works. Like this is, she's comparing this to her experience with React, which is what she was doing before Elm. And again, like just learned it on the job, totally fine. This experience, by the way, I actually ended up giving a talk about that because I was like, I don't think people like can know what that experience is like. So I ended up giving a whole talk about basically like coding in the dark, essentially like building UIs without actually opening the browser. And it's based on a real story where I was on a 4-hour flight with no Wi-Fi and couldn't actually like do any browser development because the page had to load HTTP before it could do anything. I was still productive the whole 4 hours. It was pretty cool. So I did some like live coding and kind of demonstrating to give that feel. Okay, so to make a long story short, was the experiment a success? Yes, really big success. I mean, this is probably the most successful experiment we've ever done, like by a pretty substantial margin. I mean, it's really difficult to overstate. And really, it was like we followed the same formula both times. Just find a low-risk project, it's a good fit for the technology, get it into production, then either expand incrementally or back out. So as a consequence of this, following this same procedure, in 2013, we introduced React. 2014 kind of expanded our use of it, and I started doing Elm on the side. And then 2015, we're like, cool, let's introduce a little bit of Elm. And then eventually Elm kind of took over. And at no point did we say, we're going to be an Elm shop. It was just this total gradual, like incremental experimentation. We just kind of let things evolve based on what we thought was best. And so the key was just low risk and then see if it grows. And so far, this is what ended up happening. Also in 2016, based on how well this has gone, we decided to, actually I can't take credit for this, my boss decided we should hire the guy who made Elm. And kind of his theory was like, look, this has been so great for our hiring, like how do we maintain this advantage when more companies start using Elm? Which he was right, now there's way more companies using Elm. Back then I was like, there's like 5 companies using Elm. Now there's like hundreds, thousands, I have no idea. But basically he was like, hey, let's hire the guy who made it because he's a scarce resource. So we'll continue to stand out. So he's still working here. He only works on Elm. That's all we pay him to do. So we're basically making a very direct financial contribution to open source. Like we're really giving back in not just a token way, but in like an actual like, this is like this guy's whole job. And that's all we pay him to do. We've also done some other experiments along the time, so I don't want to give you the impression like every experiment we do is a smashing success. So Terraform was something that we tried out. We thought it was like very declarative infrastructure API. We thought it would be a good fit based on stuff that had worked out well for us in the past. Didn't end up panning out, so we're actually in the process of backing that one out. GraphQL did work out. It's like not been like the wild success that Elm's been, but it's like, yeah, it's good. We're going to keep using it. And Elixir is sort of somewhere in between, where we had started using it. We got 2 Elixir services into production, like really small, sort of special purpose ones. And we decided, I think that's enough. We're not going to back them out. Like they're still running 2 years later. They're totally fine. But we basically were like, yeah, this is not what we're going to make our like new default backend technology, the way that Elm became our new default front end technology. By the way, you might be wondering, like, hey, Elixir, that's a backend technology. It's kind of a lot like Ruby. Like, what's the deal? Were you looking for a new backend technology to replace Ruby? And like, kind of, yeah. So, again, backend team feeling kind of jealous of front ends. Like, at some point we asked ourselves this question, like, what do we want our backend stack to be in 5 years? Like, there came this point where we crossed this threshold where we're like, hey, we're not a startup in survival mode anymore. We actually, like, we made it in the sense that like we're not going to die, which like for a startup, if you ever worked for one, it's like an exciting thing to realize, because usually by default most startups are like, yep, we're going to run out of money in this many months. But we kind of crossed the threshold. We're like, oh, actually we're good. We're going to be around for the long haul. We make enough money that we don't have to worry about that. And so we were kind of like thinking like 5+ years ahead, do we want to every year be expanding our Rails code base and having more and more of that built up when we've already identified kind of several problems that we've already experienced? Do we want to double and triple down on that? Or do we want to try some experiments and see if we can find something else that we'd rather invest in for the long term? So Elixir was the first thing we tried, and it was like, yeah, we like it, but it wasn't like, it didn't nail it for us. The big thing was that, whereas with Elm, one of the things that we really liked about it was the maintainability benefit, like the type system that really, really helped us out, especially with big refactors. That was a problem we were having with our Ruby code, and Elixir has this thing called dialyzer, but it's really not the same thing as like being built around a type system like Elm's was. So we were looking at this, and man, the first thing we did, we were just like, what has worked well for us? And it was like, okay, declarative over imperative, like React, Elm, SQL, all technologies that we've been very happy with. Obviously, type pure functional programming with Elm, that's worked out well. Also, build time schema checks was something else we'd like. So there's this Elm GraphQL library that basically says, okay, we can connect your GraphQL schema to your front end and make it so that if you're trying to talk to the server over GraphQL and there's something that doesn't line up, like your types are mismatched, like there's a field you're asking for that it doesn't understand, that actually fails at build time rather than waiting for it to crash and cause a problem in production. So we were happy with all those things. We're like, what can give us that same kind of experience on the back end? Is there anything? And we looked at everything. I mean, really, anything was fair game. Like, even stuff, you may not recognize all these logos. I'm very familiar with them at this point. But like, anything was fair game. I mean, even more obscure stuff than this. But you gotta remember, the more obscure the language, the more the risk, right? The more the trade-offs, the more benefits we need to see on the other side to outweigh those. And really, at the end of the day, it came down to one kind of obvious choice. Haskell, the language that I'd sort of like started out being interested in like way back in 2013. And so the reasons here were basically, it's a strongly typed pure functional language like Elm. In fact, actually, Elm and Haskell share a lot of syntax. Their type systems are pretty different, but they have a lot of the same characteristics as far as like strong runtime guarantees. Also, it has a sizable pure functional ecosystem. So a lot of the other languages we looked at, it's like, hey, F#, like F# is a functional programming language. But really, the ecosystem is mostly C#. So it's sort of like, well, as soon as you start reaching for other people's libraries, you're getting a lot of like OO mutable code that's like really not what we want to be working with. And we didn't really want to be fighting with that. Like one of the things we liked about Elm was like, yeah, there's a fewer number of Elm packages than NPM packages because there are a quadrillion NPM packages, I think, at the last count. That might be on the low end. But at the end of the day, like all the ones in Elm land, they follow all the same guarantees. So like as our Elm code base does. So they're really, really reliable. And if you're looking for a typed pure functional package ecosystem, nobody's is as big as Haskell. It's the biggest one out there by a huge margin. And also it has these really cool build time schema checks for the database. This is something that seemed really exciting, and I'm going to show a little bit of code of that later. Nevertheless, obviously there were risks. So again, much smaller ecosystem than any of the alternatives we were looking at. Learning curve even higher than Elm's. Like Haskell is notorious for having a high learning curve relative to other languages. And of course, the same question, how will we hire people? This worked out really well with Elm. Would it work out well with Haskell? We didn't really know. By the way, one of the questions I sort of asked myself, like reflecting on our experience with Elm and with React, is like, are bigger ecosystems always better? And my conclusion was no. I think it's more that there's like a minimum sort of viable size. So for example, we do not want to be writing from scratch a Haskell PostgreSQL database driver. That sounds like a really bad idea, not how we want to be spending our time. And some of the languages we thought about were like, yeah, they don't have that. Like, that's kind of a problem. We don't want to be writing a web server from scratch. But at the end of the day, it's like, in Elm, we ended up having to implement an Elm rollbar library to like log errors to rollbar. It took like a day, I mean, how much did that cost us versus being able to pluck that off the shelf with like NPM? Well, about a day. In the grand scheme of things, with as many developers as we now have and as much time as we invest in our tools, it's kind of a drop in the bucket. So kind of my conclusion was like, all right, as long as there's like a minimum level of stuff where we're not going to be spending like a month writing some package that we really need to do our jobs, like, I don't really care. I'd actually rather prioritize the ecosystem being really high quality and really cohesive over it being necessarily bigger and bigger and bigger. Like, yeah, NPM has a billion packages. Do we use a billion packages? No, we use like, a handful. Okay, JavaScript is more, but but like in Elm, we use like, I think it's like under 100 packages, out of the whole ecosystem. So really, I think there's some strong diminishing returns that really doesn't get talked about that much when factoring in technology choices. So some of the rewards we're expecting, certainly easier to maintain complex business logic. Again, this is like our biggest pain point with Ruby is there's a lot of code where it's like, yeah, making changes to this stuff is scary. Like we're like, I hope the tests are going to save us, but we do not have anywhere near the level of confidence in making changes to a lot of this really complex stuff as we do in Elm, and we don't want to keep doing that. We want to start investing in tools, hopefully, that can help us have confidence when we're making changes to complicated business logic. A more reliable backend that doesn't crash as often, Elm, no runtime exceptions. Haskell's not quite as hardcore as Elm is about that, but it's definitely like, it's unusual for a Haskell program to crash, whereas, with Ruby, it's sort of every day. And again, growing as developers, right? Haskell is on a lot of people's bucket list as a language to try. It was certainly on mine. So at the end of the day, we're like, yeah, let's do it. Let's do a controlled experiment to try out Haskell. Find a low-risk project that's a good fit, get it into production, expand incrementally, or back out. So for this one, we decided to go into sort of like NoRedInk labs, like our internal tools. So we have a lot of curriculum people who are like usually former English teachers who are designing the curriculum for our questions. And so the nice thing about doing a project for an internal service is you do have real users, real stakeholders, but they're very understanding because they work for you, or they work with you. You work for the same company. So if your system goes down because you don't have the infrastructure set up right or something like that, they're like, okay, when are you going to have it back up? As opposed to being like, forget you, I'm going to your competitor or something like that. So lower risk. Then again, we once again have this question of learning resources. Now, React was brand new when we came out, and Elm was also pretty brand new when we came out, so there wasn't a whole lot of stuff there. Haskell's a few decades old, so you'd think there would be great learning resources. There's a slight problem, though. So if you want to learn Haskell, your options are, number one, there's this like style of teaching Haskell that's like theory first and then practice. So we're going to teach you about monads and monoids and functors, and then eventually, like chapter 7, we're going to like print hello world to the screen. So that's one style. Another style is lambda calculus, then theory, then practice. You laugh, but the most popular Haskell book is that way. Chapter 1 is lambda calculus. You cannot make this stuff up. That's your second option. The third option is theory, and then category theory. So basically, if the way that you like to learn is building stuff and then learning theory, man, please come talk to me if you found a good Haskell resource that teaches that way, because I couldn't find it. And it's really, it's a cultural thing. Like Haskell came from a research language. It was not designed to be like used in like production systems in industry. It was designed to help researchers collaborate on computer science stuff. And it just ended up being used in industry. So I understand why it is that way historically, but at the end of the day, there's a huge opportunity here. If someone wants to build that resource, like, hey, teach people how to build Haskell programs by starting from building stuff and then working backwards to the theory, I think there'd be a lot of people who are really interested in that. As evidenced by the fact that I know a lot of people, in fact, when I've been telling them the title of my talk, they're like, I tried to learn Haskell several times, and it never stuck. But it turns out there is a way that we've found that's effective at teaching Haskell, which is teaching each other, pair programming. We actually have several people on the team who know Haskell well. Unlike before where it was like just me teaching everybody Elm, now that we're bigger, we actually have like multiple experienced Haskellers and they're teaching other people and now they're capable of teaching other people. Again, pair programming, it works. It's a good thing. So hopefully there will become more learning materials in the future that are sort of more practice first and then theory. But in the meantime, hey, at least for us, this is something that's worked out. So yeah, 2017, we got Haskell in production. So some things that we learned about it is, one is Haskell is like the opposite of OMAKASE. So this is a Rails term. This is something that the creators of Rails have used to describe it. So OMAKASE is a style of sushi where you go to the restaurant and you say, I would like the OMAKASE, which means that the chef is going to decide exactly which pieces of sushi you're going to get. And they've chosen them in a particular order. They're going to bring them out. They're going to make them. It's like, this will be a great meal for you. But you're letting me make all the decisions. You're not saying I want this and that and that. No. You're saying, do what you think is best. And that's kind of the Rails philosophy. So what I mean by Haskell is the opposite of that, is the first thing you decide is which language features you want. So Haskell being a research language, you can toggle on and off which like language features, like what string literals mean in the language is like something you can configure. Now again, for researchers makes great sense. For practical people, we're just like, what's the one that's good? I don't know, like, there's strings. I don't So we had to decide this, right, when we were doing our initial experiment. Also, you have to choose a standard library. There is one point of consensus here, which is you absolutely should not use the standard library that Haskell ships with. That's the one thing that everyone agrees on. You should pick a different one. So we did. We picked a different one, and we've been happy with it. And then, of course, then you need to start doing the normal stuff like choosing your server framework and whatnot. So really about as far from Rails as you can possibly get, which is not always a bad thing, but definitely something that was an unexpected thing that we learned. This is Michael Newton from England. As a language, I've really enjoyed it being Haskell. There are a lot of knobs to twiddle, no kidding. So it felt important that we'd done the R&D project first. So it was good that we had like this small initial project, and this was like why we experiment this way, where people could like figure things like that without having to get into an argument with like a 30-person team. It's just like, okay, these 3 people, they're just gonna make decisions and we're gonna run with it. And that's worked out pretty well. It's not quite as nice as having Rails that's been vetted by this enormous community, but it's good enough for us. Something Tessa Kelly, by the way, Tessa is American, but I thought it would be appropriate to put the New Mexico flag because Tessa has extreme New Mexico pride. So when I showed her this slide, she was like, yes, that's how it should be. So something we did well with Elm that we haven't done with Haskell yet is like identify a challenging area and then make it less challenging. So this is something we did with Elm where we're like, hey, we've noticed like this pattern that we do and like not everybody gets it when we start out. So like let's see if we can find a way to make it like a little bit easier and make it more approachable. We haven't really made those same kind of investments in Haskell, and I think that's something that's like an ongoing area of improvement for us. Comparing compiler error messages, I thought this was a good treat from Chris Jenkins, who's an experienced Haskell. He's like, here's how beginners see Haskell's error messages, blah, 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 line number, blah, 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 integer, I know that word, and then a bunch of gibberish. Haskell's error messages are not as nice as Elm's. Let's just leave it at that. And as a consequence of this, like Michael Glass, who lives in Berlin, said people get stuck more than in Elm in Haskell, but also people don't cause regressions, which is very different from my experience using Rails when I was just getting into it. I didn't know anything, and Rails is pretty opaque a lot of the time. It's like, oh, this did a thing. Why did it do that thing? I don't know. I just had a lot of surprises, and I definitely caused my share of regressions, maybe more than my share of regressions. So one important difference is that yes, okay, it's not as user-friendly as Elm, but at the end of the day, the guarantees that we have are really nice, and that helps people like as they're learning the language, like avoid stepping in pitfalls and causing problems. So here's an example of this. This is the typed Postgres code that I mentioned earlier. So here's what this is doing. We're calling app.modifyExactly1. We're passing in a log and db, so don't need to worry about what those go. The interesting part is here. So this is essentially kind of like a macro. This is built into the typed Postgres library. And what it's saying is, write some SQL in here, and I'm going to execute it. Now, so far, that might not sound like that interesting. Like, yeah, I can do that in active record. Give me a string, I'm going to spit it in there. But this is actually doing a lot more than that. So one thing it's doing is it's actually going to check the syntax of this to make sure it's valid SQL. Okay, all right, that's pretty nice. Another thing that it's doing is we're actually doing interpolation here. So these are variables that are in scope. Like name is a variable in my Haskell code. Desc, like description, is a code in my Haskell code. And it's actually good. It's not going to do string interpolation. It's going to do the right thing, like bind the parameters in there. So we're not vulnerable to SQL injection attacks. That's also pretty cool. The really cool part is that this is actually connecting at build time to my database and checking the schema against the types in my code. So if name is a string, but this column in the database is an int, this will not compile at build time. Like we have a complete connection between our database and our code, like as we're writing it. That is awesome. Or as Giuliano, who has an amazing beard. Actually, his facial hair like grows and contracts. Like right now, he's completely clean shaven. But I've seen him do this over the years. So he'll just like grow it out as much as possible, and then like one day he's just like boom, mustache. Like all the beard's gone. It's just like that's all that's left. And then anyway, he's from Brazil. He's awesome. He's like, hey, like the PostgreSQL typed library is my dream come true for an ORM-like thing. He did C# for many years before joining NoRedInk, and he's like, yes, this is what I always wanted. Like I can write plain SQL, so when the performance gets bad, I can drop down to the lowest level thing, and yet it's all checked and it all works. Nice. So, how was the experiment, all things considered? Yeah, definitely a success. We're continuing to use it. 2019, 2 years later, we've only expanded our use of Haskell. Some more recent experiments we've done, we've been using the Nix package manager, which is really cool. Definitely recommend checking that out. Kubernetes, Probably so you've all heard of that one. We're just like kind of trying that out in the same, using the same procedure that we have everything else. Our infrastructure folks are hoping that will solve some problems we've had. And PostGraphile, which is a pretty cool technology for sort of automatically connecting a Postgres database to a GraphQL schema, making it so that you don't have to write queries by hand. You can just say, this is the data that I want, you write the query for me. And for a lot of like really basic queries, it seems like that'll save us some time. And of course, we're proceeding with them in exactly the same way as before. Low-risk project, into production, expand incrementally, or as the case sometimes is, back it out. Okay, so what all of this has gotten us is looking back all the way back to 2013, where I was like, man, do I want to work on that product or do I want to work on that stack? Like, I had this conflicted decision to make. Now in 2019, I'm just like, hey, I'd like to work on that product and I'd like to work on that stack. So I've been very happy with my decision at NoRedInk, and this is probably a good time to mention, we're hiring. we hire remotely. I work remotely from Philadelphia, and the headquarters is in San Francisco. Obviously, we have people all over the world, Europe, South America, all over the US. And yeah, if any of this stuff sounds interesting to you, like no matter what your background is, please come talk to me. Thanks very much. So we have some time for questions. Okay, you started out with Elm on the non-rendering business logic, and it looks like now React fading out and being replaced by Elm. Accurate? Do you use them in tandem, or is all rendering done in Elm? Yeah, pretty much everything's done in Elm now. So we have about 300,000 some odd lines of Elm code in powering our front end, and JavaScript is now just like a tiny blip. So basically, like if you're doing front end programming at NoRedInk, that means doing Elm. We really haven't expanded our use of React, except kind of in that transition period where it was sort of like, okay, if you need to make a small tweak to a React thing, cool. But like if we're making a really big change, we're just like, we'll just redo it in Elm. So it's sort of evolved in a more and more Elm-like direction. Certainly all the rendering's in Elm now, yeah. Except for, we still have some legacy React, but that's about it. Other questions? Yeah?
If TypeScript was around at the time that you were switching to Elm, do you think you might have gone in that direction instead?
Oh, great question. So if TypeScript was around when we were switching to Elm, do you think we would have gone in that direction? I certainly think I would have tried it. So I actually know a good number of people who use TypeScript at work and Elm on the side, and it is not the same. Knowing what we did at the time, I'm honestly not sure. It's hard to say, because back then in 2013, I think TypeScript existed, but it was like really, really obscure at that point. So it wasn't really something we really even considered, to be honest. I'm just going to go with audience questions because I think we got one on Slido, so yeah.
I'm curious, you have a lot of a constant pipeline of new projects, like you can see the gradual migration from something like React to Elm. Do you actively transform your old React code into Elm?
Yeah, question was, do we actively transform our old React code into Elm, or do we just wait for new projects and do them in Elm? We don't actively transition our old stuff. So we actually still have some CoffeeScript left in the code base, and we had a question at some point where we're like, hey, should we just get this out of here? Just compile it to JS and just check that in so we don't have it in our build pipeline anymore. And at some point we're like, I don't know, it's not really hurting much, so we'll just leave it there. I think our philosophy is mainly we're more concerned about building new code than sort of going back and messing with existing code that's working okay. If we have a problem with it, if it's causing us significant headaches, then that's a good reason to do it. But we're not really cleaning things up just for the sake of making them cleaner. Maybe there will come a time when we change that, but for now it's more focused on building new stuff.
I just didn't know if you had a primary kind of library framework or something that you have to build off of, or something that was an older
Oh, so our older stuff is mostly React, but there's still some jQuery and I think even some Angular 1, in some dusty corner. That may have been gotten rid of, but I think it might still be there. Whereas in Elm, it's we just pretty much use it out the box. So we don't really use, there aren't really Elm frameworks that I know of that anyone really uses. I think I heard of one person once made an Elm framework and they're like, I'm making an Elm framework. And everyone was like, okay. But I don't think anyone really uses it. So yeah.
So I know that Ruby on Rails because the security and all that stuff is still in. What's the aspect of security you have in Haskell?
So what's the Haskell security story? That's a good question. So as I understand it, the way that we're doing security in Haskell is currently, as far as like authentication goes, is because we have this big Rails monolith, we're actually pretty much delegating that to Rails at the moment. So there's the possibility that in the future we'll split that into like its own authentication service. But basically it's like when the user logs in, we're just like, hey, kick that out to the Rails monolith and then do the authentication, then just like pass back a token that the Haskell service then is like, hey, monolith, is this valid or not? So pretty much for now it's all delegated. But at some point in the future, I can see us migrating more of that. But that's part of the incremental approach. Oh, is there another? Could Elm be used on the back end? Oh, great question. Yeah, so this is actually like this is such a frequently asked question that it's on the like Elm FAQ like roadmap. And the short answer is that like basically Evans, the creator of Elm, his view is basically like, if I want to do Elm on the server, like I want to do a really good job at it. I don't want to just be like, hey, it's like Elm, but now it's back-endier. He's like, I actually want to like think out like, hey, what's the best like language I could design for the back end? And maybe that looks like Elm, maybe it doesn't. But he's like, that's how we got the result of Elm on the front end, was just saying, I want to design a language to like solve these problems. And he's like, that's a huge project. And like, we're not done with the browser yet. So I appreciate that focus. So in theory, yes, but I think like not anytime soon. I think the phrasing he used was, even if we started today, it would be years away. So not something we're really thinking about that. React has millions of approaches to styles: modules, plain CSS, CSS injections. How is this handled in Elm? So Elm is like React. It's like concerned with rendering the DOM. So it doesn't have like styling built in. You can choose your own alternatives. We use Elm CSS, which is basically like CSS in Elm, like there's like CSS in JS. It's essentially the same basic idea. So you write your styles inline using plain Elm code. One nice benefit of that is that Elm CSS actually like type checks them. So like if you try to say like, I don't know, display hidden or something like that, or like display, that one sounds plausible. So float hidden, then like it won't type check. So basically the approach is up to you. That's the one that we use, but plenty of people use like, before that we just continued to use Sass and just like had separate style sheets. So that's fine. A really cool project that I cannot recommend enough is Elm UI. So Elm UI, I actually gave a talk about this. It's basically like, imagine if you didn't have CSS. Like you weren't even thinking in terms of CSS. It's like Matt Griffiths took this like goal of like, I just want to make a system for layout and styling that's really good. I'm just like, CSS is a compilation target. I'm just going to rethink all of this. And like, it doesn't use Flexbox. It compiles to Flexbox, but it's like, you don't need to know Flexbox. You don't need to know CSS cascade rules, anything about, you don't need to know any CSS at all to use this thing. And it'll lay out your whole application. And it's awesome. I really, like, people love that thing. The Elm Slack channel for Elm UI is just like, goes bananas, because it's just like, there's so many people who love it. So we're not like actually using that because we have a really big CSS code base at this point, but I think if we were starting over today, like I would absolutely start with that. So one more, yeah.
How do you decide to check out a new language, a new framework? Is that like a manager or senior engineer to do it, or do you just let an engineer like, hey, you can write a tiny app?
Oh, great question. Yeah, so the question was like, how do you decide to like that you're gonna do an experiment like this with a new language, a new technology? Is that something that like senior managers do and then it's like top down, or is it like engineers do it? Anyone can propose it. I mean, it's really like anyone can start the discussion, but like we have the discussion as a team. It's like, hey, is this something that like we plausibly want to get into? Is this like, do we want to make the investments? Do we want to do the experiment? If the experiment's successful, do we actually see ourselves adopting this? So that's more of a group discussion, but yeah, absolutely anyone can start these things. So awesome. Thanks so much.